Alright, welcome to perfect squares versus differences of squares. And I would say that these two concepts are ones that students really have trouble distinguishing, but fear not, we're going to use our simple factoring method. Remember that in order for our simple factoring method to work, we have to ask ourselves, does A equal 1? And of course, in both of these examples, we know that there is a 1 coefficient in front of the x. Now, the next question we would ask ourselves, and really and truly, guys, y'all don't have to write this out every time once you master it, but we're saying, hey, blank plus blank equals our b term, and in this case, our b term is 4, okay? So we're asking what two numbers add up to be 4, and what two numbers multiply to be our c term, which in this case is also going to be 4. Well, guys, this should be the easiest one in the world. Oh, and by the way, that should be a multiplication symbol. This should be the easiest one in the world. We know that 2 plus 2 is equal to 4, and we know that 2 times 2 is equal to 4. So what are we really saying? We're saying that if we wanted to factor this or solve it, we would just say f of x is equal to x plus 2 times x plus 2. That is what happens when we factor x squared plus 4x plus 4. Now, something interesting happens here. What if I wanted you to solve this? Well, here's the trick to solving quadratics. We always set f of x equal to 0, and then we simply ask what value of x would make these factors equal to 0? Well, it turns out that the value of x you're always looking for is going to be the opposite of our constant. So x will equal the opposite of the constant. Well, our constant is positive 2, so we'd say that this x is equal to negative 2, comma. Okay, this constant right here is a positive 2, so this x must also be a negative 2. And guys, we call this a repeated solution. And that is so key. I want y'all to know whenever we have a perfect square, we're dealing with a repeated solution. Okay, let's go ahead and take a look at our differences of squares. Now, for our differences of squares, we're actually kind of saying the same thing. Okay, it's got an a coefficient of 1, but you'll notice that right over here, we have a c coefficient, but you might be saying, hey, mister, where is the x? Well, whenever you don't see an x, what we're saying is that the b value, of x is actually a 0. When there's nothing there, our b value is equal to 0. Okay, so this one actually becomes a little bit easier. We're saying, you know what two numbers add up to be 0, and also what two numbers multiply to be our c term, which in this case is going to be negative 4. Well, when y'all think about this, you're going to think about two numbers that are the same but are opposites. And the best way to think about this is taking the square root of our constant. So what's the square root of 4? Well, the square root of 4 is 2, okay? The square root of 4 is 2, but you need it to add up to be a 0, so all you have to do is make one negative. Okay, and if we're making that one negative, that one becomes negative, and that should make sense because a negative times a positive will give us that negative. Or, more accurately, we would say this. G of x can be factored into equaling, parentheses, x minus 2 and x plus 2. Well, notice if we were to set g of x equal to 0, x minus 2, and x plus 2, we'd say this. We'd say, you know what? X is equal to the opposite of negative 2, that's positive 2, and here x is equal to the opposite of positive 2, which would in fact be negative 2. Okay, I know that's a lot to digest. Let's move on into a second example that we're going to do a little bit faster. Okay, guys, let's go ahead and tackle our example 2, and we're going to do this so quick. And how are we going to do it quick? Well, we are going to recognize that in both of these cases, our c terms are going to be perfect squares. If you ever recognize that your c term is a perfect square, well, you're probably onto something here. So, what are we going to say? We're going to say if I wanted to factor h of x, I'm just going to break it down into x times x gives me x squared. And look, guys, what is the square root of 9? Well, the square root of 9 is 3. And wait a second, how can 3's get me to 6? Well, plus 3 plus 3. When you understand it, it is that easy. Okay, now if we're going to solve this, we'd say 0 is equal to x plus 3, x plus 3. And now we're going to say, you know what is x? Well, this x is the opposite of positive 3, which will be negative 3. And this x is the opposite of positive 3, which is negative 3 again. And of course, guys, we have our repeated solution. And in fact, just so you know, anytime you have a highest exponent of 2, you need 2 solutions. Okay, let's look at our differences of squares. So here, this one is our differences of squares. We're going to say Rx is equal to x blank something x blank. And guys, we're saying, look, what is the square root of 9? Well, it's 3. But how can you take a 3 and another 3 and add them up so that our b value is equal to 0? Easy. Make one positive and one negative. So if I want to go ahead and solve this for x, well, I would say 0 is equal to, okay, x plus 3 and x minus 3. And here we would say x is equal to the opposite of positive 3, negative 3. And here x is equal to the opposite of negative 3, which would be positive 3. Alright, let's go ahead and try one more round, and I promise at the end of this you're going to crush it. Okay, here's our third and final example, and in this one we are going to talk about a perfect square. Remember, we know that this one has a perfect square here, and then this one, since it has a subtraction and a perfect square, we call it a difference of squares. Okay, how are we going to tackle this? Well, this one right here, if I want to factor it, I'll simply write f of x equals our parentheses. We know x times x gives us x squared. And you ask yourself, what is essentially the square root of 25? Well, that's 5 and that's 5. Now, how can you have two 5s combine to become a negative 10? Well, of course, we make them both negative. And so if we were going to solve for x here in this case, well, we'd say, you know what? F of x is equal to 0, x minus 5 times x minus 5. And we're going to say this x is equal to the opposite of negative 5, which is positive 5. And here, this x, which is the opposite of negative 5, which is positive 5. And once again, we have a repeated solution. Guys, remember, when you have a perfect square, you will always have a repeated solution. That 5 is there twice. Okay, y'all, let's go ahead and take a look at our differences of squares. Well, here we know g of x will break down into our two parentheses, and that x squared breaks down into x and x. And you ask yourself, what is the square root of 25? Well, of course, that is 5. That is 5. And how can we have a 5 and a 5 so that they add up to be 0 so that there's no b term? Well, of course, we have a plus 5 and a minus 5. We set g of x equal to 0. This is our method for solving quadratics. And, oh, silly Mr. Hastings, get out of here. Okay, we'll say that this x is the opposite of positive 5, that's negative 5, and this x is the opposite of negative 5, that's positive 5. Okay, y'all, so there we have our solutions to these simple quadratics. The focus, though, was on you factoring these quadratics.